Quality protects value, reputation, and user trust. It reduces rework, delays, and hidden costs. Good quality ensures the product solves the right problem. It also satisfies agreed requirements and standards. Quality is everyone's job, not just testers. It must be planned, built in, and verified. Quality choices affect scope, schedule, and cost. Balancing these factors requires clear criteria and disciplined practices. Quality management provides that structure for consistent, predictable outcomes. Quality has two complementary views. Fitness for use asks whether the deliverable meets real user needs. Conformance to requirements asks whether it matches documented specifications. Both must align to stakeholder expectations. A product can pass tests but fail users. It can delight users yet breach regulations. Aim for both fitness and conformance. Define who the users are and how they define success. Then connect their needs to measurable requirements. Turn stakeholder expectations into clear acceptance criteria. Capture functional and non-functional needs, such as performance and security. Use simple, testable language. Map criteria to user stories, features, and scope baseline. Confirm regulatory and organizational standards apply. Create a traceability matrix linking needs to tests and deliverables. Validate criteria early with stakeholders. Keep requirements versioned and accessible. Clear criteria reduce ambiguity, gold plating, and disputes. They also guide verification activities later. Quality planning defines the rules of the game. Document them in a quality management plan. Include applicable standards and guidelines. Roles and responsibilities for QA, quality assurance, and QC, quality control. Acceptance criteria and review gates. Checklists, templates, and sampling plans. Supplier and subcontractor quality expectations. Tools, environments, and data management. Escalation paths for defects and risks. Ensure the plan fits the project size and risk profile. Keep it practical and actionable. Metrics make quality visible and manageable. Use SMART measures. Typical metrics include defect density and severity trends, test coverage and first pass yield, rework rate and cycle time, uptime, response time, and error rates, customer satisfaction, and NPS. Set tolerances and control limits where useful. Specify sampling methods and frequency. Define data sources and ownership. Visualize metrics with simple dashboards. Review them regularly in governance forums. Adjust targets as the project evolves. Quality assurance is proactive and process-focused. It prevents defects before they occur. Typical activities include process definition and training, audits and process compliance reviews, supplier qualification and onboarding, standards adoption and tool governance, preventive actions from root cause findings, coaching on peer reviews and pairing practices. QA asks, are we using the right methods consistently? It strengthens capability. Strong processes produce reliable outputs at scale. Quality control is reactive and product-focused. It detects defects in deliverables. Common activities include inspections, walkthroughs, and peer reviews, functional and non-functional testing, sampling, measurement, and statistical checks, control charts and trend analysis, defect logging, triage, and retest. QC asks, do outputs meet defined criteria today? It supports acceptance decisions. QC data also informs process improvements in QA. QA and QC must reinforce each other. Consider this alignment. QA defines review checklists. QC applies them in inspections. QA trains on test design. QC executes tests and reports. QC trends reveal issues. QA drives preventive changes. QA sets supplier standards. QC verifies incoming quality. Embed feedback loops in your cadence. Use stage gates to confirm readiness. Share dashboards that integrate process and product indicators. Alignment reduces surprises and waste. Adopt simple proven tools for continuous improvement. PDCA cycles for iterative learning. Kaizen events for focused changes. Root cause analysis with 5 whys and fishbone diagrams. Pareto analysis to prioritize vital few issues. FMEA to anticipate failure modes and effects, control charts to distinguish noise from signals, checklists to prevent known errors, retrospectives to capture lessons learned, make improvements small, frequent, and measured, celebrate prevented defects, not only fixed ones, watch for traps that erode quality, gold plating beyond requirements, late testing compressed by schedule pressure, ignoring non-functional needs and compliance, vague or untestable acceptance criteria, weak supplier quality oversight, collecting data without using it, counter with practical habits, define done and acceptance upfront, shift left reviews and tests, risk-based focus on critical areas, automate repetitive checks where sensible, track cost of quality to guide investment. Quality means fitness for use and conformance to requirements. Plan quality with clear standards, roles, and measurable criteria. Use QA to strengthen processes. Use QC to verify outputs and enable acceptance. Apply improvement tools to prevent defects and reduce waste. Engage stakeholders in defining and reviewing criteria. Start small with checklists and simple dashboards. Build rhythms that blend prevention and detection. Quality is a habit, not an event. Make it visible, shared, and continuous.